What if I told you that everything you know, everything you've ever loved, is just a blink in Earth's long ancient story? That your entire life, your dreams, your memories, your civilization lives on a fragile surface of a planet that's been through cataclysm and calm, through fire and ice, through death and rebirth. This is not just the history of Earth. This is a chronicle of existence, a journey across billions of years, told not in centuries or lifetimes, but in oceans, rising and falling, continents colliding, and stars dying. From the birth of Earth in darkness to its final breath in fire. Today, you are not merely a viewer. You are a traveler through time, a witness to everything our world has ever been and everything it will become. So take a deep breath. Step into the machine. The voyage begins now. In the beginning, there was darkness. And from that darkness, a flicker, a swirl, a scream of gravity. Roughly 4.6 billion years ago, a dense cloud of gas and dust remnants of ancient stars, long since dead, collapsed under its own weight. Pressures soared, temperatures rose, and at the center of this swirling storm, our sun was born. It flared into life in a crucible of fusion, lighting up the cosmos like a divine spark. But the sun was not alone in this nursery of stars. Around it, debris whirled chaotically, rock, metal, ice colliding, merging, shattering, and reforming. This was not a place of peace, but of violence. Amid that chaos, a young world began to take shape. Earth was not born gently. It was not blue or calm or habitable. In her earliest days, she was a hellish orb of molten rock struck endlessly by meteorites. Great waves of destruction swept across her surface every few seconds. Mountains formed and crumbled, and craters erupted only to be filled with more molten fury. As you step into our metaphorical time machine and witness this infancy firsthand, the scene before you is utterly alien. The sky is dark, obscured by dust and ash. Lightning crackles through thick clouds. The ground trembles beneath your feet as new land is born and torn apart in an instant. You are standing on a world that is not yet a home, just a furnace of potential. And yet, even now, something extraordinary is happening beneath your feet. The Earth, under constant bombardment and internal pressure, begins to change from the inside out. As heavier materials settle, a silent revolution unfolds deep within her core. Iron and nickel sink toward the center. It is a descent of immense power, not chaotic, but inevitable. With every movement of metal, friction creates heat, and that heat melts more rock, accelerating the process. It is a self-feeding storm. This is the iron catastrophe, not a disaster, but a necessary transformation. The Earth is building her heart. Within a few million years, that heart stabilizes, and with it, something beautiful is born: a magnetic field. Invisible, but vital. A force that shields this young world from the solar winds, from radiation that would have stripped her atmosphere away. Without this shield, life could never have emerged. On your wrist, your left watch shows mere minutes have passed. But you're right. The one that measures local geological time tells you that millions of years have already slipped by. It's only 7 Aubers a.m. on this cosmic calendar, and yet Earth has already endured fire gravity and rebirth. From the chaos, a planet begins to breathe. A shell of crust cools at the surface, though it will not remain stable for long. The interior is still turbulent. Magma plumes burst through weak spots in the crust, forming the first volcanic islands in a sea of boiling stone. The atmosphere above is not breathable. It is a choking mix of hydrogen and helium, laced with methane, ammonia, and sulfur dioxide. Toxic, hot, and heavy. The sun, young and volatile, flickers through a hazy veil. But now something is different. The bombardments are slowing. The sky is clearing, even if only a little. Earth has a magnetic shield, a solidifying crust, and a molten core. She is still dangerous, still wild, but she is no longer just a rock in space. She is becoming a world with a story. And yet, just as things begin to settle, a threat appears in the distance. Something massive, something familiar, but wrong. Another world, a rogue sibling, is approaching. This story is far from over. For a brief moment in deep time, Earth was calm. She had endured. Fire had forged her own magnetic heart and stood battered, yet breathing. But the universe does not allow peace for long. High above the fractured crust of the proto-Earth, a mysterious light began to appear in the sky. At first, it seemed like a distant star, faint flickering. But as days passed, it grew brighter, larger, closer. This was no star. It was Theia, a wandering world roughly the size of Mars. Born from the same solar dust as Earth, Theia had been trapped in a delicate gravitational dance at Earth's Lagrange point. But this cosmic waltz was unstable. Other planets, Venus, Jupiter, Saturn, tugged at her, nudging her orbit, pushing her closer and closer toward disaster. And then it happened. At 7:02 a.m., on Earth's cosmic calendar, the sky turned dark, not from dust or ash this time, but from shadow. A curved wall of rock, larger than anything you've ever seen, filled the horizon. Theia had come too close. There was no way to escape now. Her fate and Earth's had been sealed. The collision was unimaginable, not an impact, a planetary annihilation. Two worlds met not gently, but violently, with the force of 1 billion hydrogen bombs. Mountains vaporized. Oceans of magma spilled into space. Entire chunks of Earth's crust were flung beyond the pull of gravity, scattering into orbit like shattered glass. You watch from above as Earth screams in silence. The sky glows with molten rock. A ring of incandescent debris circles the planet, glowing red and orange like Saturn in its most apocalyptic form. This was not just destruction, it was recreation. From the wreckage, a miracle rises. That ring of shattered Earth and broken Theia begins to dance once more. Gravity takes hold. Fragments clump together. Clumps become spheres. And slowly, over tens of thousands of years, these moonlets merge. A child is born from chaos. Our moon. But this was no distant orb in a quiet night sky. In the beginning, The moon loomed 30 times closer than it does today. It filled the heavens, dominating the horizon like a watchful eye. Tidal forces between Earth and Moon were immense. They pulled at each other constantly, stirring oceans that didn't yet exist, influencing seasons that had not yet begun. The moon did more than illuminate the night. It stabilized Earth's tilt, its obliquity preventing chaotic shifts in climate and helping create the long, predictable rhythms upon which life would one day depend. As you stand on this battered world, watching its first satellite rise in a sky of ash and stars, something stirs inside you. This is a sacred moment. A new balance has been struck. For the first time, Earth is no longer alone, yet beneath your feet, the ground still quakes. The planet is still wounded, still hot, still grieving the impact. But now, with a core to protect her and a moon to anchor her, Earth can begin the long road to healing. The atmosphere begins to shift. The hydrogen and helium escape into space, replaced by heavier gases like carbon dioxide, nitrogen, and traces of water vapor. Volcanoes roar across the surface, belching out the materials that will one day form oceans and clouds. And then they come, small, frozen, messengers from the void, comets. In the stillness that followed the great collision, Earth began to exhale. The violence had passed, the surface still molten, in many places slowly cooled. The air, once toxic with hydrogen and helium, now thickened with carbon dioxide and nitrogen. It was still no place for life, but the ingredients were beginning to align. And then they arrived. From the far reaches of the solar system, icy travelers plunged toward the planet, comets, billions of them. Like glowing arrows of destiny, they bombarded Earth in what scientists now call the Late Heavy Bombardment. But they were not harbingers of death. They were bearers of gifts. Each comet was a capsule frozen time machines carrying water organics and the seeds of chemistry. And as they struck the Earth, they melted into her wounds. They poured into cracks, into craters, into valleys. Steam rose, rain fell, and slowly puddles became pools, pools became lakes, lakes became oceans. Earth had found her voice, a sound we still know today. The crash of waves, the dance of tides, the whisper of water. For the first time, blue appeared on Earth's skin. Standing at the shoreline of this newborn ocean, you feel awe. There is no life here yet, no fish, no trees, no birdsong, just silence. But it is sacred, because from this water, something unimaginable is about to rise. Fast forward 300 million years, a blink in geological time. It's now January 14th on our cosmic calendar. The Earth has been soaked in water for over a week by your watch, but eons have passed for the planet. And in the shallow edges of these oceans, in the hot mineral-rich soup near ancient volcanic vents and bubbling shorelines, something stirs. Chemistry begins to flirt with complexity. In one of these quiet pools, a hot spring near what will one day be Western Australia, you kneel beside the edge. Your scanner detects an unusual ratio of carbon isotopes. Carbon-12, slightly more abundant than carbon-13. You remember this a fingerprint. A subtle clue. Because living things prefer carbon-12. You look closer. The water is warm and milky. Floating within it are tiny structures, droplets filled with sugars, proteins, and self-replicating molecules. RNA strands begin to twist-fold and make copies of themselves. Protocells bump into one another. Some break apart, some persist, and just one, gets it right. It's alive. Barely. Fragile. Vulnerable. But unmistakably alive. The first life on Earth. You stare in disbelief. This pool, this microscopic speck, is your ancestor. 4.1 billion years removed, yet connected through an unbroken chain of survival. It will take another billion years for anything more complex than bacteria to appear. But this is the genesis of biology. The first breath, the first heartbeat, the first awareness, however primitive, that it is possible to continue. As you rise, you look across the planet. Oceans now swirl with organic chemistry. Carbon-based molecules float through the currents. Lightning strikes provoke new reactions. Hydrothermal vents churn like underwater laboratories. Life is not yet abundant, but it is persistent. Over the days and weeks that follow, or what feels like days to you millions of years pass, microbes begin to colonize shallow waters. They group together into slimy photosynthetic mats called stromatolites. These strange microbial reefs will go on to dominate the Earth's shallow seas for billions of years. And though the sky is still dim, the young sun shines only 70% as bright as it does today. Earth remains warm. Thick layers of carbon dioxide wrap the planet in a greenhouse blanket, holding in precious heat. The world is quiet. There are no predators. No predators are needed. Only time and light. Because something else is about to change. Something that will both give life and take it away. The age of photosynthesis is coming. For millions of years, life remained microscopic. Tiny single-celled organisms, no eyes, no limbs, no brains drifting in the ancient seas. They replicated, competed, and adapted. Slowly, quietly. But life was already rewriting the rules of its own existence. And then, something revolutionary happened. A group of cyanobacteria, early microbes, unlocked the secret of light. They learned to absorb sunlight, and using water and carbon dioxide created their own energy. In doing so, they released a waste product that would forever change the Earth oxygen. At first, it was barely noticeable, just trace amounts seeping into the oceans. But photosynthesis was so successful, so efficient, that cyanobacteria multiplied wildly, covering shallow seafloors in vast microbial carpets. And the oxygen levels began to rise. But oxygen is a double-edged sword. To most existing life forms, oxygen was poison. It corroded cellular components. It disrupted chemical pathways. It killed. The very innovation that promised growth also brought devastation. The Great Oxygenation event began at around 2.4 billion years ago. In late February, on our cosmic calendar, oxygen transformed the oceans. It reacted with dissolved iron, causing massive rusting events. Oceans turned red as iron precipitated out, forming ancient banded iron formations we still find today. The air itself thickened with this reactive new gas, and life suffered. Over 50% of all living organisms on Earth were wiped out. A mass extinction. Silent, microscopic, forgotten. But as always, extinction is also evolution. Some organisms learned to tolerate oxygen. Others fled to oxygen-free pockets of Earth, clinging to the old ways. And from the survivors came innovation. A new type of cell, larger, more complex, more resilient, began to emerge. The eukaryote. These cells weren't just bags of chemicals anymore. They had internal compartments, organelles, each performing a specific function. They had nuclei membranes and the ability to engulf other cells and make them part of their own system. One of those engulfed cells became the mitochondrion, the powerhouse of the cell, once a free-living bacterium, now a permanent partner. Eukaryotic cells were a revolution in architecture. They were harder to destroy, more efficient, and capable of complex behaviors. But most importantly, they opened the door to something even greater: multicellular life. Two eukaryotic cells stuck together. Then 4. Then 8. Some began to specialize. One handled movement, another digestion, another protection. They divided labor-forming colonies, then organisms. On March 30th, we witnessed the first multicellular organism, a primitive jelly-like creature. Soft-bodied, floating in the seas, fragile, but organized. This was not just life. This was cooperation. The oceans began to teem with these new forms. Sponges, anemones, and other soft-bodied animals drifted through the ancient waters. Still no bones, no shells, no claws. But life was building. And Earth, with her new oxygen-rich atmosphere, was becoming ready for the next act. As oxygen levels stabilized, the ozone layer thickened, shielding life from harmful ultraviolet radiation. The skies cleared, sunlight warmed the surface, and with each passing million years, the pace of evolution quickened. Earth had endured a silent war, and from it she emerged not just living, but alive with potential. The next era would bring teeth claws, shell's eyes, and chaos. The Cambrian was coming, the Cambrian, a name that echoes through the halls of paleontology, a turning point, a biological explosion. On May 1st, in our cosmic calendar, around 541 million years ago, Earth became unrecognizable. The seas burst into complexity. Life no longer drifted passively. It swam, crawled, burrowed, hunted. Creatures developed eyes to see, jaws to bite, shells to protect. Nature began experimenting with every shape and strategy imaginable. Trilobites scuttled across the ocean floor. Anomalocaris, a nightmarish predator with rotating mouth parts, ruled the middle of the food chain. Opabinia, with 5 eyes and a claw-like proboscis, searched for prey in alien landscapes of sponge gardens and coral-like reefs. There were failures, strange, fragile, awkward creatures that disappeared as quickly as they came. But from these trials, winners emerged. Evolution began sharpening its tools. Then the land called. At first, it was colonized by simple mosses and fungi, green carpets creeping across the rocks, breaking down minerals and building the earliest soils. Soon insects followed. Millipede scorpions and eventually winged forms took to the air. Amphibians emerged from swamps, testing the boundaries between water and sky. And with time, the land became a canvas for nature's most daring experiments. Forests soared. Insects the size of eagles buzzed through oxygen-rich air. Reptiles grew larger. Some returned to the water. Others stayed and ruled the land. Then came the giants. On May 10th, in the Triassic period, the first dinosaurs appeared. They began small, swift bipedal hunters, but the stage was set for a rise like no other. Over the next 150 million years, they would become the undisputed rulers of Earth. You walk the plains of ancient Pangaea and watch them pass Allosaurus with its serrated teeth stalking the underbrush. Stegosaurus lumbering with plates along its back, swinging a spiked tail. Triceratops proud and armored, with horns ready for war. And finally, Tyrannosaurus Rex, the symbol of prehistoric power, its roar shaking the trees, its footsteps leaving craters in the mud. Life had reached a majestic crescendo. These were not just animals, they were ecosystems in motion. From the tiny feathered Microraptor to the ocean-dwelling Mosasaurus life adapted to every corner of the globe. Birds emerged from small theropod dinosaurs, learning to fly, carrying the legacy of their ancestors into the skies. But Earth does not allow dominance to last forever. On May 15th, the skies begin to darken. A rock 10 kilometers wide hurtles toward Earth. It does not slow. It does not ask permission. When it strikes, the world stops. The shockwave flattens forests. Tsunamis roar across continents. A thick blanket of dust shrouds the planet, choking out sunlight. Plants wither. The food chain collapses. And just like that, the age of dinosaurs ends. It is not total extinction. Some creatures survive. Crocodilians, birds, tiny mammals hiding in burrows. But the giants are gone. Their bones settle into the Earth's memory. The world has been emptied, but not forever. A new era is about to begin, and from the ashes of extinction, a lineage will rise, one that will build cities, paint caves, ask questions, and wonder about its place in the stars. The age of humans is just around the corner. The asteroid left a wound, but from that wound, something remarkable emerged. With the dinosaurs gone, the planet exhaled. Forests crept back across the land. The climate settled. The age of mammals had begun. At first, they were small, rat-sized creatures scurrying through leaf litter, hiding from the shadows of ancient predators. But now, the shadows were gone. The world was open, and evolution wasted no time. Mammals diversified. They grew larger. Some returned to the sea and became whales. Others climbed trees and became primates. And somewhere, in a humid forest in East Africa, a new kind of primate took its first upright step. It is May 17th, 3:48 p.m. on our cosmic clock. Homo sapiens have arrived. In the blink of an eye, we harness fire. We carve tools. We paint animals on cave walls in flickering torchlight, recording a world we're just beginning to understand. We spread out of Africa, across continents, adapting to tundra, desert, rainforest. Then we build villages, temples, cities. Civilizations rise along rivers and coastlines. Mesopotamia, the Nile, the Indus, the Yellow River. We worship stars, We invent writing. We fight wars. We draw borders. We compose music. We love. We destroy. We imagine gods and write poems about the moon. The pace is staggering. Just 13 minutes after we appear, we enter the Neolithic Revolution, farming, domesticating animals, forging the rhythms of settled life. And less than 1 minute after that, a mere 20,000 years by local time, we vanish. Gone. The cities crumble. Steel rusts. Books decay. Satellites fall from the sky. Our monuments, our cathedrals, statues, and skyscrapers are swallowed by forests and sand. Winds carry away our last traces. What happened? Did we burn too bright, too fast? Did we poison the air, the soil, the seas? Did we go quiet, a peaceful extinction, or violent in fire and war? Or maybe we left. Maybe we became something more light-based, machine-born, post-biological. Perhaps we left Earth behind, not in death, but in transcendence. There are no answers now, only questions. But what is clear, painfully clear, is how short our chapter was. Less than a minute in Earth's 12-month story. A breath, a heartbeat, and now the stage is empty again. The planet spins on her skies, clearing her wounds, healing. But something has changed. No new civilization rises. No successor takes the torch. The golden age of life is beginning to dim. And a long, slow decline is about to begin. We are not here to see it, but you are. As the last human footprint is washed away, you look back on our time on us and realize how fragile we were, how extraordinary, how fleeting. The story continues, but the age of thinking, dreaming, questioning life is over. And now, Earth belongs once again to the quiet. 3 days have passed since humanity disappeared. Just 3 days on the cosmic calendar, a blink in cosmic time. But Earth is already changing. The continents long drifting, like slow dancers on a stone floor, begin to reunite. Plate tectonics pulls them together into a new supercontinent, an echo of the ancient Pangaea. Mountain ranges collide, forming great spines of rock across the land. Deserts stretch, oceans narrow. The Earth looks familiar and yet alien. But the most dramatic change is not what's beneath our feet. It's what burns in the sky, the sun. Over the past 4.5 billion years, our sun has been slowly growing hotter. This isn't a punishment. It's simply physics. As hydrogen is fused into helium deep within the sun's core, the balance shifts. Gravity contracts the core. Pressure rises. Fusion increases. The sun shines brighter. 30% brighter than it did when Earth was young. And now that heat begins to tip the planet out of balance. Evaporation accelerates. The water cycle spins faster. Clouds thicken then dissipate. Rainfall increases, pulling more and more carbon dioxide out of the atmosphere. The droplets of water, slightly acidic with dissolved CO2, break down rocks in a process called chemical weathering. That carbon is locked away in ocean sediments, never to return. The Earth is running out of breath. Carbon dioxide, the gas once feared by humanity, once blamed for climate change, is vanishing. But CO2 is not a villain. It is the foundation of photosynthesis. It feeds the plants, which feed the animals, which feed the biosphere. And now it's disappearing. By May 27th, CO2 levels have fallen so low that plant productivity is half of what it was during the age of mammals. Forests shrink. Grasses vanish. The food chain collapses again, not in fire, but in hunger. You watch it unfold in fast motion. Animals become rare. The greens of earth fade to browns, then grays. Life clings on where it can in shaded valleys, alpine lakes, deep roots, but each year survival becomes harder. The sun keeps warming. The CO2 keeps falling. On June 1st, CO2 drops below 150 parts per million. C3 plants, the majority of Earth's flora, cannot photosynthesize efficiently. They die off in droves. Only a few species survive, those that use the more resilient C4 pathway. Maize, millet, sugarcane, their wild equivalents hang on a little longer. But this is only a stay of execution. Because by June 13th, in the year 900 million AD, carbon dioxide levels drop below 10 ppm. Even C4 photosynthesis collapses. The last green leaves shrivel in the sun. The last blade of grass falls. The age of photosynthesis is over, and with it, oxygen begins to vanish. The atmosphere, once filled with the breath of forests, begins to thin. Herbivores die first. There is nothing left to eat. Carnivores follow. Mammals perish, their complex lungs too dependent on high oxygen levels. Even birds fall silent. The oceans long a refuge grow still, as fish suffocate and sink. Even the insects disappear. It is a quiet apocalypse. Within a span of just a few hours, on your watch, just a few million years, in real time, Earth is transformed from a lush, vibrant world teeming with biodiversity to a planet of microbial survivors. But don't mistake this for a return to simplicity. The life that remains, bacteria, archaea, extremophiles, is far more advanced than the life that once emerged in shallow pools 4 billion years ago. It has endured every mass extinction, every climate shift, every catastrophe. Its genetic code has been honed by countless generations of natural selection. It is small, yes, but it is the apex of endurance. These microbes migrate to the poles, to high-altitude lakes, to underground aquifers. They adapt to salt heat radiation. They do not fear the coming drought. They do not mourn what has been lost. To them, this is simply the next chapter. And yet even they cannot survive forever. Because Earth is heating up. With carbon dioxide gone, Earth has lost its thermostat. There is nothing left to buffer the rising energy from the sun. The temperature soars. The oceans begin to boil. Salinity increases. Surface water evaporates into thick, steaming clouds. Life flees deeper into rock, into shadow, into silence. But the silence is temporary, because soon even the Earth's core will fall silent. And then, the planet will begin to die, not in chaos, but in stillness. The Earth is no longer recognizable. Her forests are gone. Her oceans, once endless roaring alive, have boiled away. Her skies are heavy with vapor and salt. The poles, once sanctuaries for microbial life, now sear under a sun that grows brighter each century. But this isn't the end. Not yet. Far below the surface, Earth's heart, the molten outer core, has been cooling for billions of years. And now, in this lonely, quiet chapter, it freezes. On July 25th, the core solidifies completely. The magnetic field that once protected Earth from cosmic radiation collapses. Charged particles from the sun stream directly into the atmosphere, stripping away what little remains. Without that invisible shield, radiation sterilizes the surface. The temperature, over 100 degrees Celsius globally. With no water, no atmosphere worth speaking of, and no protection from the sun, the Earth has become a barren wasteland, more like Mercury or Venus than the planet we once called home. The process is now irreversible. The upper atmosphere grows thick with water vapor. In a phenomenon known as the moist greenhouse effect, the sun's ultraviolet light begins to break water molecules apart, splitting them into hydrogen and oxygen. Hydrogen, being light, escapes into space. Oxygen, with nothing left to bind, to oxidizes what remains of the crust, or simply lingers toxic and useless. It's a death by evaporation. By the end of July, around the year 5 billion AD, the last reserves of water are gone. The oceans that once nourished trilobites, dinosaurs, and dreamers are dust. Plate tectonics grinds to a halt. The continents lock in place. Volcanoes go silent. Mountains without uplift begin to crumble. Winds erode them down to stumps. The biosphere, once Earth's proudest legacy, has vanished. Only rock remains, and above it, the sun keeps growing. For 5 billion years, it has fused hydrogen into helium. Now, the hydrogen at its core is nearly gone. With no more fuel, gravity begins to win. The sun contracts. Pressure and temperature soar. And then, in a sudden surge of power, a new shell of hydrogen around the core ignites. The sun expands, slowly at first, then faster. It enters the red giant phase, transforming into a swollen, bloated star, hundreds of times larger than its former self. It glows, not white, but deep orange, and red, terrifyingly beautiful. December 31st has arrived, Earth's final day. At 9:15 p.m., Mercury is swallowed whole. At 11:16 p.m., Venus disappears in fire, and Earth she holds on. Her orbit, widened by the sun's mass loss, gives her a fleeting hope of escape. But gravity is not kind. It reaches out. It drags her closer, and then, at 11:59 p.m., Earth is caught in the sun's chromosphere, the outer layer of searing plasma. Her crust burns. Her mantle liquefies. Her orbit collapses. There is no scream, no flash, just silence as the Earth. Our cradle, our storyteller, our only home, returns to the star that gave her life. After 12 billion years, the story ends. But perhaps not all is lost. We forget how rare this moment is. We live in Earth's golden age, not just in time, but in balance. A stable orbit, a breathable atmosphere, liquid water, active geology, a magnetic field, and above all, life, diverse, creative, conscious. We walk in sunlight filtered by an ozone layer. We sleep under stars protected by a magnetic shield. We breathe the breath of trees. We drink the tears of ancient comets. We dream in the quiet between catastrophes. We are lucky, unfathomably lucky, but luck is not a guarantee. The story of Earth shows us that nothing lasts. Not oceans, not empires, not even worlds. And yet we are here, not just surviving, but wondering. We have the power to destroy and the power to preserve. The candle hasn't gone out yet. New stars are being born. New planets are forming. The universe is vast beyond imagination. Somewhere out there, another Earth may be waiting. Or maybe, just maybe, we'll be the ones to build it. Because while Earth's story may end in fire, the story of life doesn't have to. And what happens next is up to us.